function 4, we're still comparing functions, but in this learning target, we are going to be able to describe quantitatively, which means by quantities or numbers, the functional relationship between two quantities by analyzing a graph. So we're still comparing, but this time we're going to look at numbers in a graph. So a couple things when you're analyzing functions and graphs. There will be a couple words we use. So it says we can analyze parts of the function by describing them as increasing when we look at graphs or decreasing. And we can call them linear, which means a line graph, or a nonlinear. And there are multiple ideas of nonlinear. You will look at them in Algebra 1 and Algebra 2 as you go through the high school. So it says describe the parts of the function shown below. So between when x is 0 and x is 4. So this is where x is 0, this is where x is 4. So if we look at the graph, it's between these two values. So we can say that is increasing, because you can see it's going up, like kind of like a roller coaster. You're increasing. And this is not a straight line. Okay, it's got a curve to it, so this is nonlinear. And again, non in this case is just going to be not linear, or not, and you can see the word line in there, not a line. If we go between 4, where we just were, and 8, which is right here, so between these, if you look at this right here, that would be, if you're on that roller coaster, you're going down. So this is a decreasing. We could compare them. And again, still nonlinear because it still has a curve. Okay, we're going to spend some time looking at distance versus time. So we're going to kind of look at these graphs. So it says a distance versus time graph shows us how far two objects are from one another. Consider what the following types of line on a line or distance versus time graph would represent. So if we look at this first one here, this is your distance, this is your time. So 0, whatever I'm measuring in, 0, whatever I'm measuring. So we could say 0 minutes, 0 distance in feet. Okay, so as I go increase in this linear fashion, okay, as time is going up, so is the distance. See how that's also increasing? So we could say this object, because let's say you're here, this object is moving away from us. So an object is moving away. Because again, this is where it'd be 0 feet. So if you're way out here, maybe that's 5 minutes and 300 feet. You're moving away. You're getting further away from whatever. And I'm going to write at a constant, because it's linear, speed. Okay, let's look at the next one here. So this one, we have distance here. So let's say we're 0 time, and we're already so far away. Let's say 50 feet. So this is decreasing. So as time is increasing, notice the distance is decreasing. So you're getting closer to wherever you're going, because let's say we're 50 feet, and then you're at 40, 30, 20, 5 feet here. So as time goes on, you're getting closer. So an object is moving closer. Oh my gosh. And notice that it's a line, so it's linear. So we can also say at a constant speed. The last one, so here's our time. So that's 0, but notice the distance, let's say that's 30 feet, stays the same. So as time, let's say 1 minute, 2 minutes, 3, 4, 5, 6, the distance stays the same. So this object's at rest, or it's not moving. Distance. Or we can, I'll just say, and not changing distance. So it stopped for a while. Didn't get closer, didn't get further away, just to staying that same distance. This is kind of like going to your friend's house and you're not getting further away from your house. You're just kind of sitting there the same for whatever many of hours. Okay, we're going to look at this. So notice it's increasing in nonlinear. So this object is also, we kind of already talked about this object is moving away and increasing. And we'll talk about the word speed, because if you notice, it's getting steeper and steeper and steeper. This was constant. It's the same speed. It's a straight line, but this one starts out slow and then all of a sudden they take off. So you can say an object is moving away still and increasing speed. It's not steady. It's definitely going faster. And the last one here, this one, notice that it's nonlinear and it's increasing. I should say it's decreasing in speed, because notice it goes fast and then all of a sudden it starts to flatten line out. So it's going fast and then slower, almost to that rest stage where they're not moving. So an object is still moving away, and is decreasing in speed. So let's look at some graphs here. So here's our graph. We're going to call this segment right here F, and then this is G, and this is H, and this is I and J, and then we're going to call that K, and then a slight change, L, M, and N. So those letters that are underneath represent the intervals. So your intervals are just a difference between changes here. So first question is, well, first of all, it's Valerie decides to go for a bike ride. Her goal is to travel 200 kilometers in less than 12 hours. So I'm going to label these graphs so it makes more sense. So your independent, or your X, is time in hours. And your dependent is distance in kilometers. So if you notice this whole graph, she is going away from her original, or the starting point, and sometimes she's going a lot faster and sometimes she's resting. The steeper the line, the faster, or the speed is greater. So the first question is, what intervals does Valerie's distance increase over time? So in other words, when is the graph at an increase? So I can say F here, because from 0 to 3 hours, she's increasing at a linear rate. G not, that is a flat line. H, she's increasing. I, she's going even faster. Notice it's steeper. J, she's resting again. K, she's increasing. You can see it go up. L, she's going a little bit faster. There's a slight change in slope there. M, she's sitting still. And N. So we'll write those intervals down. So intervals, this is intervals in time, so between hours. F, H, I, K, L, and N. At which interval does she travel the fastest? So if you kind of look, you're looking at slope, and we could do a little slope work here. So that change of 50 over 3. So my rise is 50, my run was 3. So 50 over 3, if I divide that so I can get my unit rate, That'd be 16 and 2/3. The whole graph wants to move on me. There we go. This one doesn't have a slope. This one, it looks like you're going up 10, 20. So it looks like 20 over from 4 hours to 6 hours. So this is 20 over 2. I'll write that above here. 20 over 2, which is 10 over 1. So here she's traveling 10 kilometers in 1 hour. This one's 16 and 2/3 kilometers in 1 hour. So this one is faster. So H is out of the runnings. I, so that's 10, 20, 30. And then that's 1 hour. So this one's 30 over 1. So that's even faster, which shouldn't surprise you because it's steeper. It almost looks about this, but honestly, it's actually a lot steeper. So F's out of the running. K, looks like it starts here. And whoops, I went too far. Starts here and it goes to here. And some of these we might have to guess because they're not perfect. So this is 10, 20, maybe that's 10, 20, 25. We'll say it's 25 over, and then each of these are, looks like 2/10. So 2, 4, 6, 8, 10, 1, so 1.4. So if you take 25 divided by 1.4, that's about 17.8. 17.8. So that's not any faster than the steeper one, and you can kind of see how steep that one is. So this one's out. So it looks like a half. It looks like 25 again. 25, it'll be a little easier because that's over 1. But our highest is down here at 30, so that one's out. And then we end up with N. So it looks like it's here up to here. So that's definitely 50 going up. Because it's 115, that's 200. It's the time here. I'll look at down here. Let's go 2, 4, 6, 8. 8. 2, 4, 6, 8, and 1. So we're going to go 50 over 1. It's close. But I could tell that this was going to be your steepest because you kind of look at all those increasing. This one has the steepest. So this is the math to prove it. So which interval is Valerie traveling the fastest? That would be interval N. How many breaks did Valerie take? And how are the breaks represented on the graph? So the breaks, let's put them in purple here. So anytime it's horizontal line, that means the time's going on, but the distance hasn't changed. So she sits for an hour and rest here at 50 kilometers. Then she gets going for a while, and then she sits here and rests here at J. It looks like approximately about a half an hour at 100 kilometers. Then she takes off again, and then she stops again for M. So she's at 150 kilometers for about a half an hour. So she takes 3 breaks during her bike ride for almost 12 hours. So 3 breaks, and how are they represented? The breaks are shown by a horizontal line. And we'll look at our last example. It says Brandon takes the day off to drive the countryside. The graph below represents his trip. Okay, and we're going to use the letters below. So I don't want you to pay attention to these capital letters. We're going to use kind of like we did last time. So he's driving the countryside. So on F, he's going away and then he must take a break, and then he's going faster away, but then he turns around, he's coming closer, because now he's only 50 kilometers, or whatever we're measuring in. And then he goes for a while at a pretty good time, and then he stops, and then he's headed back towards, I'm guessing, home pretty fast, and then even fast. Oh no, that's actually slower. And then he's home again after 11, and it doesn't tell us what we're measuring in, but we know this is time and this is distance of some sort. So what intervals does Brandon travel away from home? That would have been F, H. There, he's going away from home. Let's cross out the K because I think those are all one. And then L, he's sitting still, and then M and N, he's headed home. So intervals, it looks like F, H, and I'm just going to call it J instead of the K. What intervals is he traveling towards home? So that's when it's going back down or decreasing. So that's at, I assume that's an I, J, L, M, and then N. So he's headed back at intervals I, M, and N. And then what is happening at G and I? So G here, and I guess that's an I, so this must be an L. It's okay. We'll make that an L. What's happening is it's not moving. So the time's going on, but his distance is not moving. So we could say he took a break. The distance doesn't change. As time goes on. Okay, so some kind of break. He's just sitting there. Maybe he's enjoying a sunrise. Maybe he decided to stop and get something to eat. But time is going forward while the distance is staying the same.